Very much, guys. Good job. And next on the agenda is James Castle, Dr. James Castle from Boeing, and he will be talking about the MAI cold spray effort, the cold spray effort that's going on. And James, are you on? Looks like you're muted. If
Can you hear me now?
there you go. Yep. Perfect.
All right, super. We share. Why is it not sharing? It's worked when we practiced.
Sometimes it does take a second to start up.
It's not sharing. Oh, here we go. Now it's working. It was struggling. The whole VPN thing with everybody in Boeing on VPN at once. All right, you guys see one screen?
You're good to go.
All right. So this presentation is to talk about the Metals Affordability Initiative, BA-22, BA-24 program, which is a cold spray structural repair program. This is a team that has both the Air Force Research Lab and the Army Research Lab working together with an industry consortium that includes, led by Boeing, that includes Lockheed, Honeywell, Rolls-Royce, and Howmet. So some thoughts that I had as we've been talking to folks about non-structural and structural repairs to our different customers. The argument is always that non-structural repairs can be done today. And one of the initial conversations that come off of that is that can that be done on structural parts? And the answer is yes, non-structural repairs can be done on structural parts. The biggest challenge we have with non-structural repairs is simply the certification time that you have to have in place. It may not be structural, but there's still a significant amount of processes and procedures necessary to implement these, and I think that's what's pacing us as far as the non-structural repairs being implemented across the industry. The other thing that goes on is all these non-structural repairs where you are typically on a structural part, which means that as you blend down to clear out the damage or whatnot before you do the cold spray, you may be a few thousandths from your non-structural repair suddenly becoming structural. So one of the things we've been seeing is that it's really necessary that as we plan non-structural repairs to be thinking in terms of converting it into a structural repair as it crosses those thresholds. So different changes of equipment plans, processing plans, procedures, everything kind of has to line up with, okay, I want to make sure that I'm making this adaptable so that as I get allowables for structural repairs, I can make that change. So when we start talking to our customers, and Boeing's got a lot of platforms out there, we see no shortage of needs. It's not a problem at all trying to find a place where they need cold spray. The most common places we saw were corrosion, especially like at upper skins. Basically under every door you could find, there's corrosion. The second thing that we saw lots of was damaged holes. So you take the access panel on and off enough times, and that hole gets messed up a little bit, so you oversize it, and then you take it on and off enough times, you have to oversize it again. Eventually you can't oversize it. And the same thing with the substructure, so you end up having to fix holes. And then the last is wear surfaces. So constantly getting brought to us different wear surfaces. So these three things we saw constantly as potential for cold spray, and every platform has needs in these areas pretty much. And also the first thing they come back to us and say is, can I get load credit? Can you give me load credit? So as an industry, we have to figure out how to get ourselves to the point of load credit. So I've talked to you guys about this before. So our Air Force colleagues have pointed out that you can kind of bucketize or use these kind of classifications as a way of helping to explain that not all cold spray repairs are created equal. The reality is it's a good way to explain it, but the reality is we have a continuum. We've got different low margins, we've got different criticalities, we've got different purpose, and we have all of those sometimes on the exact same part. So it is a bit of a challenge to come up with some of these like classification repairs, like, hey, I'm going to come up with this repair procedure, and you can use it everywhere that has this classification or whatnot. It's hard to do because it's more of a continuum. You can have a little bit of it. You can do this classification here, you can do this classification here, and it's really hard to come up with that general case because of the diversity of repairs that are out there. So that analysis time, that engineering time necessary in designing the repair and in coming up with as general of repair as possible is a significant factor in us getting the structural repairs. So certification requirements. So there are these 5 Lincoln pillars to kind of lay out that we have to hit. Stability, producibility, predictability, then the property characterization, i.e. the static properties, and then the supportability, like the service life properties, like fatigue life and whatnot. So the 2 MAI programs that we've had, BA-22 and BA-24, touched all 5 of these, but they're not, touched to the point that it's like you can check it off, it's done. BA-24 will have a significant focus on property characterization and fatigue, both in static and then fatigue and corrosion. But it's not going to solve every possible thing out there. But we have, as the industry, we have to get through all of these things. The first 3 there, stability, producibility, and predictability, we don't just have to get there that we can achieve those things. We have to get there where we have a whole supply chain that can achieve those things. And that's kind of, we know we can achieve those things in one place with everything locked down. But what happens with, like the discussion earlier about, I have multiple different machines out of place. I have different sites, same machine, different sites. I have different little tweaks between them. How do we get it so that it's, as a supply chain, we have all those under control? So what does it look like in static? So what you see here is basically a bimetallic sample. It's got a 0.2 substrate and a 0.1 cold spray, cold intention. What you see is the 0.3 substrate would be like the original part. The 0.2 substrate would be like a part that had been ground down to remove corrosion down to 0.2. And the cold spray repair is filling it back in up to 0.3. And so what you see is you recover a large portion of the original capability in static, which is a good sign. We're seeing very clearly that when we pull tensile specimens, we're getting significant load credit back on static. Same thing happens at fatigue life. So if you look at these fatigue coupons here, the far right is for a coupon where half of it was blended out due to corrosion. The second from the right is where a third of it was blended out due to corrosion. And then what you see, the next one over is if I just made the whole thing out of cold spray. So if I had 100% thickness out of cold spray, I'm getting better than a 66% of remaining ligament. If I then take the half blend, half cold spray situation, I've got 1,000% improvement in fatigue life by having that cold spray carrying load. If I hit that 33%, that's about a 400% improvement. But neither of them gets all the way back to blueprint, but it's still a huge improvement over where we are currently. Currently, if you have corrosion, you got to remove it. So you blend it out, and you just have whatever metal you have left. If you put cold spray on there and get that improvement, we see really good opportunities to extend the life of parts and extend the life of airplanes. Where do we want to be? I don't want to have to analyze this like crazy. I want to put the cold spray on and have it be as good as a new part. I want to be able to have the cold spray be equivalent to base metal. And I think that's one of the places we got to look at as industry is how can we get there? Can we develop the processes? Can we develop the materials that allow us to have the cold spray just be plopped on and with the spec basically saying this is as good as base metal? I realize that may be pie in the sky, but there's an awful lot of analysis that goes into deciding exactly where you fall in between. So working towards that stretch goal is something I'd like to see. What's missing in the current work that I see, and now some of this is being covered by other of you in this group. So one I see is for structural repair is non-destructive testing and evaluation. Being able to have an NDT method that says that repair is good whenever you put it on and when it's sitting there, as opposed to as a way of saying what analysis, I think is a very essential thing that is not part of this MAI program, but I'd very much like to see going on. Another is AMB basis allowables, MMPDS. are we going to have to do A and B basis allowables for every combination of cold spray and base metal? Are we going to have to do MMPDS values? Or what are we going to do them for? Are we going to do it just for the cold spray? Are we going to do it for the joint? Are we going to do it for a joint that's 1/3 cold spray and 2/3 base metal? There's a lot of questions that has to be answered there about what those allowables look like, and we're definitely going down that path. But at the end of our program, we're going to have a good package that says that, hey, structural repairs are definitely feasible, but there's still work that needs to be done to figure out what the best way is to officially certify structural repairs. I talked a little bit about the maturity of the first 3 Lincoln pillars. You don't do everything inside of Boeing, so it's not good enough if there's a Boeing lab that can do it perfectly. We don't do everything inside the government, so it's not good enough there can be a government lab to do everything perfect. We've got to have a whole supply chain that can produce the same results every time, regardless of which operator is there or which site you're doing it at, and whatnot. There's a program called BA-26 coming soon that's going to address a good bit of the stability, producibility, and predictability, and I'm looking forward to that. Next is low helium and nitrogen carrier gases. So I've seen a little bit of the presentations here on helium recovery, which is exciting. But in nitrogen is another, looking at what you can get with nitrogen for structural repair. So I don't, this is just simply something that needs to be addressed due to cost of helium as well as and whatnot. The last is legacy material substrates. We have a whole lot of different aluminums and titaniums and steels flying out there. When you look at structural repairs, the first thought that comes to people's heads is if I'm going to spray 7050, I'm going to spray 7050 on top of 7050. I don't want to have to create a million different powders for every single substrate that's out there. There are substrates out there flying that we need to repair that there's no way that solvents is ever going to make the powder make that powder for us. So looking at what the right powder it is to spray on multiple substrates and whether or whatnot is an area that I see as needing development. And that's all I had. I realized it was a very short snapshot, but it's 10 minutes, so. And thanks for the opportunity.
All right. Thank you, Jamie. All right, so I had a couple quick questions come in. So regarding NDT, are you working with any particular NDT techniques that you can share?
So this is an area where my colleagues in the NDT area at Boeing are getting engaged. I'm not going to be able to share exactly what they're working on at this point in time because it's not my area or whatnot. The reason I say it's missing from the current work is I don't have funding to go out and explore a bunch of NDTs. So I was listing it here as this is an important area that I would like to see more of as opportunity allows.
Okay, and I guess related to that is in-process inspection. So I guess what they mean is like layer by layer inspection of the surface. Is that can that be substituted for NDT in your mind, or do you need the inspection to be after the fact?
I don't have a clear answer on that. I think this kind of falls into if we can figure out a way to consistently get a great result that way. I think it's open to. I think these things are open to possibilities. I don't know the answer on that. I just know that the reality is we do these cold spray repairs, and the question is was it good or not? And if we have some way of saying whether we watch these certain process variables and we're putting it down, we spray these witness coupons at the same time. Maybe we did what you just said there of inspecting layer by layer, and then we have an inspection afterwards. If we can combine those together and say this is our spec for making a process spec for making a good cold spray repair, then I'm all for it. This is an area that I think is a little bit challenging with cold spray due to the nature of the cold spray deposit on top of the metal with the solid bond it has.
Okay, so this last one should be an easy one. What is BA-26?
So that program is focused on change management. So basically it's a little bit like machine learning, where you're pulling all the process parameters and relating all those process parameters to the end performance and fault distributions. So it's a program that's focused on how you control all your inputs and how that relates.
But I guess it's another MAI program
another
too,
MAI
correct?
program. I apologize. I should have been more clear.
Yeah, okay. No problem, no problem. All right, well, I think that is it. Thank you very much, James.